So this is my interactive module planning template, and the whole lesson is really on the atomic basics, just learning how atomic particles and the symbols on the periodic table relate to one another. The very basics of chemistry, essentially. And I'll be using a PowerPoint to present pretty much all this information, and the target audience is just any high schooler who's taking chemistry. Will be mostly high school sophomores, but occasionally possibly a junior. So for my first objective, the students will just given a copy of the periodic table and the symbols for various isotopes. They have to be able to identify all of the subatomic particles in each isotope. And before really the lesson starts, I'm going to have them fill out a Google form, just to see how much they know about this topic, because this is really the core of chemistry right here. So I want to see how many students are coming into really chemistry no idea what's going on, and then maybe some other students who already are familiar with some of the material. And then so actually starting the lesson, they're just going to start off by watching a simple PowerPoint presentation, just learning what the different parts of the atomic symbol represent, and then they'll go on to being asked some basic examples. Through Edpuzzle, they'll watch a video and answer some questions along the way, being asked some basic questions about finding, either protons, neutrons, or electrons in an isotope. And then really the final part of the lesson before the assessment, or really the assessment itself, they just have to use the periodic table to find the numbers of protons, neutrons, and electrons in each isotope, and they're using an interactive PowerPoint to do this. And the actual questions, so the PowerPoint will contain the information, and there will be a few questions on the Weebly website that they can go on and answer for their assessment. Learning objective 2, just given a copy of the periodic table and some isotopic abundance data, they'll be able to calculate an average atomic mass. So in order to begin the activity, it's important that they have basic algebra skills, because it's crucial for this kind of thing. It's crucial in pretty much all of chemistry, so it's important that they understand this stuff. So they're just going to watch a YouTube video just to kind of review the basic algebra skills. All students taking chemistry should have had algebra at this point. It's just a simple review. And then they'll go on to watch just a short little presentation to learn what exactly an average atomic mass is. And then they'll go on, again, using Edpuzzle, just a great example, just to see someone do all the math themselves, to understand the process, watch a video, answer some questions along the way, so they can just because it is a multi-step process. It's important that students understand what's going on at each step. And then finally, much like the last activity, they're going to just be given some questions. In this case, they're only going to be given one question. They'll just have to calculate the average atomic mass of a certain element that I give them, and then they will actually use the periodic table to check their work, because the answer they get should be the same mass on the periodic table. So that'll kind of help reinforce the idea that the average atomic mass is the mass that's found in the periodic table. And again, the problem will be found on the Weebly website. And then for my final learning objective, just given a copy of the periodic table, various elements, the students will have to write noble gas and full electron configurations of these elements. So they'll begin the lesson with an online simulation, kind of like a chemistry lab sort of thing, just learning what an electron configuration is and how to write one. And seeing why these configurations matter. And by playing with the simulation, they'll be able to kind of work in a virtual lab to see, to realize that electron configurations are largely what cause chemical reactions to happen. So and then after that, they'll watch a short video that explains the concept. So in the simulation, they'll see like what happens due to electron configurations, and then they'll be explained what electron configurations are after they've seen them being used in action by watching a video on Edpuzzle. And then they'll watch a short presentation to learn the notation to learn how to write electron configurations and how to notate them. And then finally, after that, again, just a little bit of assessment. They'll have to write their own electron configurations for a few elements. Again, the questions to answer for their assessment will be on Weebly. And then to develop the content, again, just a PowerPoint presentation with all the links embedded in it. And then all the tools and resources I mentioned are listed right here.